Hello. So in this video, we will be going over all of the questions from the midterm review packet relating to Unit 4. So that's going to be questions 18 through 24. Okay, so this unit was all about chemical nomenclature. So learning how to write chemical formulas, how to name chemical compounds, etc. So question 18 sort of covers all that background information just to remind us about what types of things form ionic compounds, what types of things form molecular compounds, as well as how things become ions, etc., and what types of bonds are holding them together. So again, you should be following along in your midterm review packet, but we will go through these questions. Okay, so starting with 18A, it says, where are the metals on the periodic table? And 18B says, where are the nonmetals? So the first thing we need to do, let me pull up a periodic table. So if we're looking at our periodic table here, you can see that this one even has some color coding. It's more specific than we've been so far. But the important part is that there's a big dividing line on our periodic table. So our dividing line goes right here. It's a very rough sketch, but essentially everything, let me make this a little bit larger. Here we go. So everything to the left of that stair line, so basically everything over here are the metals. And everything to the right, so essentially everything over here, are the nonmetals. Now there's one exception, and that exception is hydrogen. Hydrogen is a nonmetal, even though it is on the left side of the periodic table, but it's a gas, so that's the only exception. All of the ones down here would still be metals. So you can see there are way more metals than nonmetals. Okay, so that's the first thing we need to remember. So let's jot that information down for question A. Okay, so we said that our metals were to the left of the stair line. And our nonmetals were to the right of the stair line. Plus hydrogen, that was the exception. Okay, so there we go. For C and D, they go together as well. C says, what elements form anions, and what does that mean in terms of the number of electrons compared to the neutral atom? And then D asks about cations. So we've got a lot of things we need to do there. So the first thing, let's remind ourselves what these terms mean. So what is an anion and what is a cation? Okay, so that's the first thing we need to know. So we need to know that anions have negative charges. Right, so that's any ion with a negative charge, and cations are any ion with a positive charge. Right, so that's the first thing we want to know. Now, what else does it ask? What does this mean in terms of the number of electrons compared to the neutral atom? So the other way we could phrase that is essentially, how did it become an how did it become an ion? Did it gain or lose electrons? Right. So for our anions, which also just to add here, our anions are formed from nonmetals, right? All the ions with the negative charges were on the right side of the periodic table. So to form an anion, what had to happen is that an atom gained electrons. So there are more electrons than protons. Compared to that neutral atom. Okay? For a cation, cations become positive because an atom actually lost electrons, which means there are more protons than electrons. Oops. 1 second, missed a word there. There we go. Okay? So make sure we know the difference between those terms. For part E here, what does it mean if a compound is made up of all nonmetals? If it's made up of all nonmetals, that means we have a molecular compound, which we could also call a covalent compound, because it's held together with covalent bonds. All right, so that means essentially how this is being held together, just a refresher on what covalent bonds really are. That means that the electrons are shared between all of the atoms in the bonds. Okay, so there we are. And then our last question, 18F, what kinds of elements form ionic compounds? So that was the other main type of compound we talked about. Ionic compounds form from a metal plus a nonmetal. So essentially something from both sides of that stair line. Or we could have a polyatomic ion. Right? Because if it's a polyatomic ion, that would imply that it's also ionic. Okay? So the difference there is that in an ionic bond, electrons are transferred. It's a complete transfer from the metal to the nonmetal. All right, so there's all of our background information. The most important things to keep in mind are probably this question and this question, because we need to, looking at a name or a formula, we need to decide if it's ionic or molecular before we can actually write the formula or name it. So keep those in mind as we work our way through. So now on to question 19 and 20. So question 19 asks about the number of valence electrons. So this was sort of the very first thing we talked about way back in the beginning of the unit. So just to remember, there was a trick. So the trick was, if you look at the last digit of the group number, so look at last digit of group number, that's going to be your number of valence electrons, which again was the number of electrons in that outermost energy shell, essentially. Okay, so carbon's in group 14 and oxygen's in group 16. So if we look at the last digit, that means that carbon would have 4 valence electrons and oxygen would have 6 valence electrons. And why that's relevant, the number of valence electrons affects what charges these particular atoms will have. So if we move to question 20, if we're asked to figure out what charge they would have as an ion, if you know how many valence electrons they have, you can figure out if that particular element will gain or lose electrons to get to 8 electrons in its outermost shell. Or, if you don't think of it that way, or if you didn't cover this part, you can also figure out the charge based on where that particular element is on the periodic table. So if I pull my periodic table up again, we can look at the specific charges associated with certain groups. So by now you're probably used to writing this on your periodic table, or at least seeing it a lot. But let's just make sure we have them. So group 1, all those ions have charges of +1. All the elements in group 2 have charges of +2. +3 is actually group 13 over here. We didn't have a charge for 14 because they weren't set. Group 15 was -3. 16 was -2. 17 was -1, and we had no charge for group 18. They don't really form ions. So anything that's in a group that doesn't have a set charge, you would need a Roman numeral for, but we'll worry about that later. For now, if I just find phosphorus and calcium on the periodic table, we see that phosphorus is right here, so it's going to have a charge of -3, and calcium's right here, so that's going to have a charge of +2. So that would make, just to keep our terminology straight, since this is negative, this would be an anion, and since this one was positive, that would make it a cation. Okay, so now we'll go into the actual questions with our formula writing. So we'll move on to question 21. So before we move on to the questions where we're actually formula writing and naming, let's remind ourselves how we know whether something is ionic or molecular. Okay? So if something is ionic, remember that meant it was made of a metal plus a nonmetal, or a polyatomic ion, which I'm just going to abbreviate PAI. Okay, so if you're looking at the formula, you would have to see if you had a metal and a nonmetal. If you're looking at the name, it's very easy to tell because there will be no prefixes. Okay, so that's one of our options, whether something was ionic. Our other choice is to look and see if it's molecular. So how would we know if something was molecular? In order for something to be molecular, it's made up of all nonmetals. So all of the elements, if you're looking at the formula, have to be nonmetals. If you're looking at the name, it's easy to tell because every name that's for a molecular compound will have a prefix in it. Okay? So we have much more extensive notes on this back from Unit 4, so you can look back at those. We made flowcharts and other things as well. But those are sort of the key pieces. Okay? So now keeping that in mind, let's move on to question 21. So, in question 21, it's asking us to first label it as ionic or molecular and then actually name it, okay? So let's do the I versus M first, okay? So if we do the I versus M first thing let's look at is, do we see any polyatomic ions? And the answer is yes. I see one here and here. So that makes D and F ionic, okay? Now everything else is binary. I just have two elements. So I have to actually look at where they are in the periodic table. If they are all nonmetals, it will be molecular. If even one of them is a metal, it will be ionic, okay? So for A, we see that carbon and oxygen are both nonmetals, so this is molecular. For B, sodium is a metal, so that makes this thing ionic. For C, calcium is a metal, so this is also ionic. And then for E, phosphorus and oxygen are both nonmetals, making this thing molecular. Okay? So now that I have my distinctions there, now I want to actually name them. Okay? So how are we going to do that? Let's do the molecular ones first, because those were sort of the easier ones. Okay? So if something was molecular, we took the element name, and you attached prefixes saying how many of them there were. So for A, I'm going to write carbon, and I have 2 oxygens, so the prefix for 2 is di, so I would write dioxide, and that's it. For E, I have 2 phosphorus atoms there, so I would say diphosphorus. And then penta is 5, so pentoxide. And that's my full formula. My full name. Remember, we still change the ending of that second word to "ide." And our first word only gets a prefix if it's 2 or higher. Okay? Now for all of the ionic ones. Let's do all of the binary ones first. So for the binary ones, you do the element name for the first element, and then the element name ending in "ide" for the second. So NaCl would be sodium, because Na is sodium, and chlorine would become chloride. Again, you're changing the ending of that element name to IDE. For C, Ca is calcium, and F is fluorine, so we would say fluoride. Oops. There we go. All right. For D and F, they both have polyatomic ions. So for both of those, you don't change the ending of the polyatomic ion name. You just look it up on your reference sheet and see what it is. So for D, Al is aluminum, and CO3 is the polyatomic ion. If you look on your list, you'll see that it is called carbonate. So I just write that. Okay. Now for F, it's going to be similar, but there's one thing we have to look for. If you look at where iron is on the periodic table, you're going to see that it is a transition metal. It's in the middle section that we do not have a set charge for. So because of that, we have to use a Roman numeral for this one, because we need to know what is the charge on the ion, because otherwise we wouldn't know. Okay, so for now let's just do the naming. Fe we already said was iron. We'll need to figure out the Roman numeral in a moment. And OH, if you look that up on your reference list, because that is a polyatomic ion, you would see that that is hydroxide. Okay, so now we just need to figure out our Roman numeral and we'll be done with this one. Okay, so let me erase this stuff. When we were trying to figure out our Roman numerals, what we did was we split our compound down the center, cation versus anion, and you always start with the anion because that's the one that we know a charge for. So if you look on your reference sheet, you'll see that hydroxides are always a charge of -1. Okay, but by the way our formula is written, there are 3 of them. So -1 times 3 means that we have a total of -3 from the anion. Ionic compounds are neutral overall, so if I have a total of -3 on the right, I need to have a total of +3 on the left to balance it out. Okay? Now our last step is just to look here. Do I have a number there? No, I don't. So really it's a 1, meaning that 1 iron must be +3 all on its own. Essentially what we did was +3 divided by 1. Okay? So now I know that this is iron 3 hydroxide, and we write that as a Roman numeral. Okay, so that is the sampling of our naming. Now we'll move on to question 22, where we're doing the opposite. We're doing formula writing. Okay, so for these, again, we first have to decide whether it's ionic or molecular, so let's do that part first. When you're looking at the names, it's even easier to tell. If there is a prefix, it's molecular. If there is not, it's ionic. So where do I see prefixes? I see mono, I see di and tetra, and that's it. Okay, so that means B and E are the only molecular ones. Everything else will be ionic. We also could have known that these were ionic because the Roman numerals here would give that away, and phosphate is a polyatomic ion. Okay, so there are a couple ways we could tell, but the prefix, non-prefix is the easiest way. So now let's name these. For the ionic ones, we have to first write all the ions, crisscross them to get our final formula. So I'm going to write underneath all of these our ions so that we remember. Now we're only doing the ionic ones at the moment, okay? So for cobalt 2, remember the Roman numeral tells you the charge on this first thing. So our ion would be CO with a +2 charge. Nitrate, if you look it up on your reference list, it ends in 8, so it is a polyatomic ion, is NO3 with a -1 charge. So now what we want to do is take these two charges, crisscross them, and make them subscripts. If we do that, let's write what we get left over. We would get CO with a subscript of 1, but we don't write the subscripts of 1, so I'm just going to write CO, and then we'll write NO3. But since we brought this 2 down here, I need to put this whole thing in parentheses and put the 2 outside to show that I have 2 of that entire formula. Okay, so there's that one. Now moving on to the next ionic one, which was C. Aluminum, if we look on the periodic table, is in group 13 that all had charges of +3. Oxygen, oxide is really oxygen, so oxygen is in group 16 and they all had charges of -2. So again, if we crisscross those and make them subscripts, we don't care about the charges once they're swapped, so we'll just write Al2O3. Okay, moving on to D, same idea. Ammonium, if you're having trouble finding this on the periodic table, it's because it's not actually there. Ammonium is a polyatomic ion. It's NH4 with a +1 charge. Phosphate, again, it ending in 8, that means it's a polyatomic ion. Look it up on your chart and you'll see that it is PO4 with a -3 charge. So if I cross this 1 down here and this 3 down here, we would get NH4. And since we're bringing a 3 down, we're going to need parentheses around that polyatomic ion. Anytime the charge you're bringing down is 2 or higher to a polyatomic ion, it needs to be in parentheses. And then we had PO4, but we were bringing down a 1, so I don't need parentheses. It would just be NH4, 3, PO4. And then last but not least, looking at F. Again, Roman numeral is telling us the charge on that. So copper is Cu, and it has a +2 charge. Sulfate is the polyatomic ion, SO4 -2. So if we crisscross these, notice that both of those 2's, before I crisscross actually, notice that both of these 2's would actually reduce to 1's. So now if I crisscross them, I just get CuSO4, no parentheses or anything. Okay? So our last 2 are the molecular ones, and these were a little bit easier because you don't have to write the ions first because there aren't actually ions. All you do is write the symbol for the element along with the prefix on that same element. So looking at B, carbon is C, and then monoxide means we have 1 oxygen, so it's just CO, and that's it. For E, di means 2, so I'll write the symbol for phosphorus with a subscript of 2. And then tetra is 4, so I'll write the symbol for oxygen with a subscript of 4. When you're doing molecular ones, you do not reduce, whereas with the ionic ones, you do. So that would be a sampling of some of our formula writing, okay? So moving on to our last 2 questions of the Unit 4 section. These are sort of being precursors for Unit 5, where we're going to be doing some balancing and so forth with our chemical reactions, but we'll do them now just so we have them complete, okay? So for the first one, 23, it says write the symbol and the charge for the ions associated with these. So essentially it's just checking that you understand what the charges are on different ions and where they came from, okay? So Ca is calcium, and calcium always has a +2 charge, okay? And F is fluorine, so if you look at fluorine on the chart on your periodic table, you'll see it always has a -1 charge. Aluminum is in group 13, so it always has a charge of +3. And CO3 is a polyatomic ion, so look on your chart and you'll see that it has a charge of -2. OH, I'm going to start with that one this time, is the hydroxide ion. The reason I skipped over the first one is because iron can actually have a couple different charges. It doesn't have a set charge. So if we figure it out, based on the way this is written, again, doing our little box essentially, we would get that hydroxides are -1 each, but since there were 3 of them, -1 times 3 would be -3. So to balance it out, this side has to be +3, and since there's only one of them here, 3 divided by 1 means that our iron is iron 3 hydroxide, so that means our formula for that other ion would just be iron with a +3 charge. Okay, so again, it's sort of working backwards from what we did before, but it's just checking you know where these, what charges these ions have. Okay, for our last question, question 24, it's asking you to count up how many of each type of atom we have. So again, this really could be in Unit 5. It's kind of a precursor to balancing, but we'll make sure we understand what we're doing here. So what we're doing is counting up each element and how many we have. So for 24B, I only have 1 magnesium written there. This 2 on the outside of the parentheses will distribute to the chlorine and the oxygen. So that means our chlorine we only have 2 of, but our oxygen we have 4 because 2 times 2 gives us 4. So there we are for that one. For this next one, the coefficient in front distributes to everything in the formula. So that means I multiply by this, and by that. Okay, so I would have 2 aluminum atoms in this thing. I would have 2 phosphorus, but since this already had a subscript of 4 for the oxygen, and we're multiplying it by the 2 in the front, 4 times 2 would be 8. Okay, and then for our last one, again, we have this distributing to everything, and we have some coefficients, some subscripts, so we've got a couple things to keep track of here. So let's look at the nitrogen. The nitrogen, it has a distributed subscript of 3, multiplied by this coefficient in front of 3, so we would get 9. For the hydrogen, I have, again, this distribution there, so that's going to be 3 times 4, which would be 12, but also multiplied by that 3 in the front of the whole thing, we would get 36. For our phosphorus, this one's a little bit easier. It doesn't already have a subscript, so 3 times 1 means we just have 3 phosphorus. And then last but not least, our oxygen. Our oxygen has a subscript of 4 to start, multiplied by that coefficient of 3 in the front, so we get 12 oxygens. So being able to count up the individual elements is going to be helpful for when we do balancing in the next section and formula writing and so forth. So those were all of the Unit 4 questions. The next video will cover Unit 5.